Good morning, guys. I'm R. Vasnakumar, Assistant Professor Mechanical, KSR College of Engineering. Now we discuss about wind energy conversion system. The wind energy can extracted from lift force alone or drag force alone or combination of lift and drag forces. The lift force acts perpendicular to the airflow direction and the drag force acts parallel to the wind direction. The lift is produced by the change in velocity of airstream which speeds up the air flow, thereby creating a pressure drop. The pressure drop forces the lift surface from high pressure side to low pressure side of an aerofoil. If the aero pressure increases on the low pressure side, enormous turbulences is produced which reduces the lift force and it leads to increase the drag significantly called stalling. The basic features which characterize lift and drag are as follows. First, drag is in the direction of airflow, lift is perpendicular to the direction of airflow. Generation of lift always causes a certain amount of drag to be developed. With good aerofoil, the lift produced can be 30 times greater than the drag. Lift devices are generally more efficient than the drag devices. Environmental concerns. Wind power is clean renewable energy source. There are however some environmental considerations to keep in mind when planning a wind power scheme. They include the following: electromagnetic interface, second one noise, third one visual impacts. Main component of wind energy conversion systems. First one is the wind turbine. It's the main component of wind energy conversion system. Is the windmill or wind turbines alone. A system of blades fixed on the tower is rotated by the wind to either produce mechanical work or electrical energy. The nacelle, it includes gearbox, low and high speed shaft, generator controller and brake. It is placed on the top of the tower and it is connected to the rotor. Next one, rotor. The hub and the blades together compose the rotor. Most of the horizontal axis wind turbine use two or three blades in an upwind design. The blades are manufactured from fiberglass, reinforced polyester, or wood laminators, or steel or aluminum. Next one is hub and shaft. The rotor of the wind turbine are attached with the shaft and hub assembly. The hub is front portion of the shaft which faces the wind direction. It is normally of conical shape. The other end of the shaft is attached to the transmission system of the wind turbine. Next one is the anemometer. This device is used for the measurement of speed. The wind speed is also fed to the controller as it is one of the variable of controlling pitch, angle and yaw. Then another one is transmission system. The mechanical power generated by the wind turbine is transmitted to the electric generator by the transmission system located in the nacelle. The transmission system contains a gearbox, clutch and braking system to stop the rotor in an emergency. The purpose of the gearbox is to increase the speed of the rotor typically from 20 to 50 rpm or from 1000 to 1500 rpm, which is required for driving the most type of electrical generators. The transmission system must be designed by high dynamic torque loads due to the fluctuating power output from the rotor. Next one is the electrical generator. There are two main options for the generator used in constant speed wind turbines, namely asynchronous or synchronous generators. Most of the grid connected wind turbines installed in so far use induction generators. These turbines have to be connected to the electricity grid before they can generate electricity. Next one is the yaw control system. It is used to continuously orient the rotor in the direction of the wind. The horizontal axis wind turbine has a yaw control system that runs the knuckle according to the actual wind direction using a rotary actuator attached to the gear ring at the top of the wind tower. Next one is the storage. There are different energy storage system available to the store energy. Storage system are used to store the energy when there is excess power developed and is discharged it, then there is a lack of power. The most common storage devices is lead acid battery. Next one is the energy converters. The electricity produces from wind energy is direct current, so it should be converted into alternating current using an alternator before supplying it to the transmission grid for industrial and household appliances. Next one is the tower. Wind turbines are kept high towers due to light in weight. In addition, wind turbines use lightweight towers that conventional mechanical windmills. Working of the wind energy system. The common wind turbine with the horizontal axis is simple in principle, yet the design of the complete system, especially a large one that would produce electric power economically, is complex. It is of prime importance that the components such as rotor, transmission, generator, and tower should not be as efficient as possible, but also they must function effectively in combinations. The main rotor shaft and electrical generator at the top of the tower, and it must be pointed into the wind. The small turbines are pointed by the simple wind vane, while large turbines generally use of wind sensor coupled with the servo motor. Most of them have a gearbox which turns the blades slowly into the quickened rotation, which is more suitable to drive an electrical generator. A tower produces turbulence behind it. The turbine is usually pointed upwind of the tower. Turbine blades are made stiff to prevent blades from being pushed into the tower by high winds. The blades are placed at the considerable distance in front of the tower, and they are sometimes tilted up a small amount. Downwind machines have been built despite the problem of turbulence because they do not need an additional mechanism for keeping in line with the wind and high winds. The blades can be allowed to bend, which reduces their swept area and thus it reduces their wind resistance. Since cyclic turbulence may be lead to fatigue failures, most horizontal axis wind turbines are upwind machines. Thank you.